Well, I couldn't really zoom in anymore, but here we are on the very bottom, so 2.5, page 4C. And let's do this one together. Now, the first two application exercises, we created two equations that we then substituted one in for the other to create one equation, one unknown. Let's see what happens with number 40. Here's what it reads. After a 30% reduction, you purchase a DVD player for $98. What was the price before the reduction? So let's take a deep cleansing breath. Read that again. After a 30% reduction, you purchase a DVD player for $98. What was the price before the reduction? Okay, so we are going to identify our goal. First of all, before we jump in and try to solve this thing, let's make sure we understand what we're after. So we want the price before the reduction. So our goal is to find the price before the reduction, before it went on sale. Okay, so some people you might rephrase that to make more sense for you. Maybe original price. Okay, let's call that, let's see, shall I use P for the original price? Maybe just X. I'm trying to see if there's more than one variable involved here. Let's go for, yeah, I'll just call it P for price. Okay, so that's what I'm trying to find here. So just one answer that I'm going for, which tells me that if I'm just finding one answer, that's kind of my clue that there's probably going to only be one equation. When there were two answers to find, probably two equations. Okay, so it's pretty much a straightforward type of situation. Okay, let's read this again. Pull out some things that jump out as keywords, highlights. After a 30% reduction, you purchase a DVD player for $98. What was the price before the reduction? So you kind of bring some knowledge to this problem. It's kind of a bring your own formula, bring your own knowledge thing, where there's the final cost here, the final price, which is what we're trying to find, is equal to the original price. So actually, I'm sorry, we're not trying to find the final price. We're trying to find the final, yeah, let's call it the final sale price is equal to the original price minus the reduction. Okay. Now there's more than one way to set up this problem. We can talk about that. So we're taking a 30% reduction here. So if I have my final sale price, they give that to us. This is a given piece of information. This is the final sale price of $98. And it's equal to the original price. That's what we're trying to find. This is our unknown that we're trying to find. So that'll be our p-value. So 98 equals p minus whatever this reduction is. It's a 30% reduction. So minus 30% reduction. Okay. Now here's where you've got to bring some knowledge. And this is why I picked this problem to do as an example, because you need to bring some knowledge about percent and how it works. That's why right before this section they had us work with percent a little bit to get us fresh on that in 2.4. So minus a 30% reduction. Well, what that means is that this original price represents 100%, and we're taking away 30%. So we're taking away 30% of the original price. That's what a 30% reduction means. It means of the original price. And of, whenever you hear yourself say of in terms of percents and things like that, that's going to be like multiplying. So you're taking 30% of P and percents. Remember, percents to decimals. Alphabetically, to go from P to D, we'd be headed to the left. So percents to decimals. We're going to move that decimal here. And P, this is going to be 98 is equal to P minus 0.30 of the original price. So it's multiplied by the original price, 0.3 of that times the original will tell you a 30% reduction. Okay? So let me say that just one more, see if I can say that a little bit differently. A 30% reduction, what you're bringing to this problem is the knowledge of what that means. It started at 100% of the price, and you're subtracting 30% of the price. So 100% is as if you've got one p sitting right here. That represents 100%. Okay, 100%. When you move the decimal, that's equal to 1.0, or just 1. Okay, so we've got 100%. We're taking away 30% of that price. You can't just take away 0.3. You're not taking away 30 cents. You're taking away 30%. So for every 100 pennies, you're taking 30 away. So you have to multiply that by the original price to see how much you're actually taking away. So that's how percent works on that. So let's look at what we would do next. We've got our translation, we've got our equation, now we jump into solving. Any parentheses? No. Any like terms? Most definitely. We've got two p's on one side here we need to combine. If I subtract 1p minus 0.3p, if you line those up, decimals, okay, you're going to end up with 0.7. So 98 is equal to 0.7p. I always put that 0 in front of the decimal so I don't lose track that it's a decimal, okay? Kind of my signal for myself. Now, some of you may have translated this and written the original problem just like this, because if I have a 30% sale, I must be paying 70% of the price. 98 must represent 70% of the original price. Some of you may have gone to a direct translation right to this equation. Okay, so 70% of the original price is what I'm paying here. That's what this equation represents. All right, then I apply my undoing here. It's being multiplied by 0.7, and that's the only thing that's happening to p, so that's the only thing we have to do is undo the multiplication. We use division to do that, and 98 divided by 0.7 is going to give you 140. Because of the situation, we're talking about price here, that gets an extra label attached to finish the story. So it's $140, so we always want a label to finish the story. Okay? All right, we'll see you on page 5.